So I'm here to help you out with section 4.5, the suggested homework problems, and we're going to work on A and C of 4.57. So we'll start off with this first one. You have 10 mils of 0.05 molar HCl, hydrochloric acid, that you would like to neutralize with a solution of 0.1 molar sodium hydroxide, and so we'd like to know what volume of that sodium hydroxide do we need to add to that. And one, kind of starter on this, if you want to kind of think about it, is this is a more concentrated solution, the sodium hydroxide compared to the HCl. So just at the outset, you might think we probably need less than 10 mils, and that would be correct. But now we're going to do that quantitatively. So I've written down a neutralization reaction, and this is the first step in this kinds of problems, because you need to know how much sodium hydroxide you need, that is on a molecule by molecule basis. How many molecules of sodium hydroxide do you need to neutralize one molecule of HCl? And I've already written this as a balanced equation, and you can see it's a one-to-one. That is, one molecule of HCl to one molecule of sodium hydroxide. So the idea is that once I figure out how many molecules or moles of sodium of HCl I have in that solution, I'll just equate that to the number of moles of sodium hydroxide. So how are we going to get this number here? Well, we have an equation that tells us the number of moles in a given solute in a given solution. Yes, number of moles is equal to the concentration of the solute times the volume that you have. And well, that's pretty straightforward, I think. If I want to know how many moles of HCl I have, the concentration is 0.05, and I'm going to multiply that by 10 milliliters. And if you work out the units on this, you'll see, well, I mean, obviously the number is 0.5, and the units are millimole, because that's in milliliters, and I'm multiplying it by moles per liter. Okay, so that's fine. And as I said before, since it's a one-to-one stoichiometric ratio between the HCl and the sodium hydroxide, I know that I need to add 0.05 millimoles, 0.5 millimoles of sodium hydroxide. And then finally, how do I know what volume of sodium hydroxide do I need to add? You can almost intuit this, but let's just go ahead and work it out. I know that I'm going to use this equation here. I know that I need N of 0.5, and I know the concentration is 0.1. So if I solve this for the volume, I have V is equal to N over C, and the N is 0.5, and the concentration is 0.1. So I need 5 milliliters. All right, so we need 5 milliliters of the sodium hydroxide to neutralize the 10 milliliters of the HCl. Once again, that shouldn't be a surprise, because the sodium hydroxide is got twice the concentration as the HCl. Okay, we'll work on C now. And for starters, I think well, let's see what's going to happen. We still have 0.1 molar sodium hydroxide that we're going to add to this solution, but there's a couple of differences. One, instead of 10 mils, we now have 50 mils, so there's going to be more sodium hydroxide that we need. But also look at how much different the concentration is. Instead of 0.05, we got 0.215. And finally, the acid is different. Okay, so the first thing to do is to write down the neutralization reaction. I've written all the components of it here, but if you want to hit pause and balance that equation, that would be good. Okay, so I'm looking at this, and I know that sulfate is a 2-, so that's an H2SO4. And in the end, that means I'm going to need 2 sodium plus 1s for every sulfate. That means I'm going to need a 2 here and a 2 there, and that's a balanced equation. So what this is telling me is that I'm going to need now 2 molecules of sodium hydroxide for every sulfuric acid. That's good, but even maybe before we worry about that, I should find out how much sulfuric acid I have. Well, once again, I'm going to use this solute equation, the concentration of the sulfuric acid times the volume. So the concentration of that is 0.215 molar of the sulfuric, and then I'm going to multiply that by 50. Okay, and that looks like it's going to be about 10.7 millimoles, okay, millimoles of sulfuric acid. Okay, and let's see. Now I have to figure out how much sodium hydroxide I need for that. That's where this equation is going to come in pretty importantly. I know that for every molecule or mole of sulfuric acid, I need 2 of sodium hydroxide. So it looks like I'm going to need, 21.5 millimoles of the sodium hydroxide, because that's twice that amount. Now the rest of the problem is pretty similar to the one that we just did. I'd like to know the volume of the 0.1 molar sodium hydroxide. That's that number. So once again, I just take the number of moles divided by the concentration of the sodium hydroxide. So that looks like it's 21.5 divided by, let's see, the concentration, which is 0.1, and resulting in 215 milliliters of the sodium hydroxide solution will be required to do that neutralization. Okay.